Hello friends, welcome to my channel. So today let's have a look at a genuine interview question. So here is the problem statement. So a company has an experiences product where you choose activities to do with your friends, and each activity has a start time, end time, and interest level. So if you are given a list of potential experiences or interest levels, like here, so we want to write a method that returns the maximum interest level if we choose non-overlapping experiences. So here by non-overlapping, it means that the corresponding intervals start time and end time has no overlap. So here a note is that, so for the first one we have 2, 5, and here we have 5, 10. So these two intervals are regarded as non-overlapping. So for the examples here, so the output is 20. So we can choose the corresponding entries marked with the pound. For example, here, so this one is 3, 6, and the interest level is 6. And then we have 8, 9. So the interest level is 5. So 3, 6, and 8, 9 do not have overlap. So this together 11. So we include this one. So we have 12, and then this 14 and 16. So we have 8. So this is the problem statement. So actually, this, as we mentioned at the very beginning, so this is a genuine interview question. So here, when we look at these questions, so we might be think of or connect this problem with the interval merge type problem. Actually, in my playlist, we have a such playlist called interval merge problem. So you can check the solution there. So here, for this problem, I'm going to provide a solution based on dynamic programming. So here I will write a dynamic programming solution, and then we're going to discuss optimizations. So here, let's begin. So first, so we want to maximize the interest level. So notice that as long as the intervals are non-overlapping, so the order actually does not play a role. So we can freely sorting the experience list. So this way we can bring us some ingredient or convenience. So with that said, let's move to the coding part. So I'm going to write a function. I'm going to call it max level maybe. So we accept an array. So the array is something like experiences, right? It's a list of tuples. So each tuple contains 3 components: start time, end time, and interest level. So first, I'm going to sort this array. So here I'm going to sort in place. So here we're going to pass it a key. So lambda. So this is the general element in the list. So I'm going to sort according to the first one and also the second component. So this way, the start is sorting in an increasing order. So in other words, if a tuple appears later, then its start would be larger than the previous starts. So after that, let me also get the length of this array. So this is just for convenience. First, I'm going to treat a special case. So if n equals 1, so we can assume that this array is non-empty. So if it's empty, so we just need to return 0, or that's a very special case. So for the edge case, when n equals 1, so we just need to return the corresponding interest level. That is the array element. So the last component, that's the level, right? So otherwise, I'm going to initialize a DP table. So here we'll set to be 0 times n, right? So after that, so we first set the first element. So here, let me first introduce the DP interpretation. So the DPI would be the maximal interest level we can obtain ending at index I. So here I mean inclusive, right? So let's write this. So because we want to include the current array elements, so the in the DP update rule, so we are going to have a specific relation. So first, I'm going to set this to be array 0, -1, and then we want to do DP update. So that's DP update. So basically, we have set the first one, so we are going to iterate from the second one up to the last one, and then we get the start, end, and the level to be array I, right? And then we want to specify DPI. So let's consider this single interval and at index I. So this will have a level given here. Let's first assume that, and then we're going to update it. So here level. Now let's here first I'm going to write a for loop. I'm going to check if the current interval has overlap with the previous one. If not, we can add the result in the previous one. So basically for j in range, so let's iterate from I-1 to the beginning. So basically we have, this is the previous start, previous end, and level. So level is dummy now. So we have array G, right? So we want to check if there's overlap. So basically we want to check if the current start is greater than or equal to previous end. So this case is non-overlapping, right? So if non-overlapping, so basically we can do this DPI equals max. So we can consider the corresponding DP value, that is if we're ending at G, because the current time interval has no overlap, so we can add the current level, right? And also we want to compare with the current DP state. So this is our main logic. Then afterwards, basically we want to return the max of the DP, right? So this will be the advanced solution format. So before we make any comments, let's first do a check. So hit finished. So now let's first this means that the function is okay. Now let's print out the result for max level. So experiences. So let's check if it's 20. Yeah, it passes the test case. So this provides a solution format to the problem. So here is some optimizations. A direct one is that, for example, so here we just we use the start and the previous end, right? So this we do not need to specify, so we can use a dummy one. So we use the start, so we can use it as dummy. So now let's test again. Yeah, it's okay. So the first one is that we can just write it more clean, right? So the second one is that so we can use a running variable rather than, so for example we can do result equals dp 0. So here actually it's not right. So here we need to read dp 0, right? Somehow it's still right. Let's test that. Yeah, it's right. So here's the first one, right? So now we can do something like this. So we can have a result, running variable, result variable to be 0, or to be yeah, we write already here result equals dp0. So each time after we set this one, so we can do this result equals max result and dpi, right? So this way we just need to return the result. So this is another maybe slight optimization. So here we have this one. So we're going to use a running result variable. So the third one I will leave as an extension. So here, right, so because we have sorted according to the first and the second one. So here, when we check overlap, so if we match with some interval, there's no overlapping. So actually, we can already stop because the previous one is also smaller. So this is the you can try early stopping or break. So another thing is that because the second component is also sorted, you can use binary search to search the point to stop where to stop, right? So for example, you can use bisect module in Python. So here, due to the time, so I'm going to leave this as an exercise for you. So it's actually good to try and practice binary search. So with that said, basically that's about it for this video. Thank you.